Hello everybody, this is Dr. G. In this video, we are going to go over 2021 free response question number 6. This problem is a sequence and series problem. The function g has derivatives of all orders for all real numbers. The Maclaurin series, so c equals 0, for g is given by this sigma notation. Part A, state the conditions necessary to use integral test to determine the convergence of the series, and use the integral test to show it converges. Part A, given sigma n from 0 to infinity 1 over e to the n, the corresponding function will be 1 over e to the x. If we look at this function, this is the same thing as 1 over e to the x. This is an exponential function with the base 1 over e. As we know, 1 over e is less than 1 because e is approximately 2.7. So we can see here the function fx is positive, decreasing, and continuous. So all the three conditions are satisfied, so we can use the integral test to check if this series converges or not. So integration from 0 to infinity 1 over e to the x dx. This gives us negative 1 over e to the x, 0 to infinity. Now we plug everything in, it's negative. When we plug infinity in, that gives us 0. When we plug 1 in, gives us 1. So our final answer, 1. Because the integration gives us a constant, so the original series converges. Part B, use a limit comparison test with series in Part A to show that the series g of 1 converges absolutely. So in order to show a series converges absolutely, we have to check the absolute value of the series. By using limit comparison test, limit as n go to infinity, we find the ratio between the two terms. This gives us 1/2. So we get a constant. That means these two series will have the same property because we know the series here, 1 over e to the n, converges. So sigma converges. Because the absolute value converges, so original series converges absolutely. Part C, determine the radius of convergence of Maclaurin series for G. So in order to find the radius of convergence, we have to find the ratio. Limit n go to infinity, g n plus 1 over g of n. So we plug n plus 1 in. So this will give us negative 1 n plus 1 times x to the n plus 1 over, it's very tedious. We divide by gn, it's the same thing. We multiply by its inverse. Because we have absolute value, so this negative 1 is gone. X is cancelled, and we have 1x in the numerator. We can get, as n go to infinity, we can ignore this 3. This will give us limit n go to infinity, x times 1 over e, give us x over e. So the ratio has to be less than 1. So x absolute value less than e. By comparing, because the center is 0, x minus c less than r. So r equals e. This is our radius of convergence. Part D. Use the first two terms of the series to approximate g of 1. Use alternating series error bound to determine the upper bound for the error. So alternating series error bound is given by the next term. Because we use the first two terms, so n equals 0 and n equals 1. The next term will be n equals 2. So we plug n equals 2 in, will be negative 1 squared over 2e squared plus 3. Give us 1 over 2e squared plus 3. This is our error bound. For part C, they only ask you the radius of convergence. So we can stop right here. But sometimes they also ask you what's the interval of convergence. So after we get to the radius of convergence, so x is between negative e to e. We also need to check the boundaries. I'm going to show you how. So when x equals negative e, we plug negative e in, we get infinity, 0 to infinity, negative 1 to the n times negative e to the n over 2e to the n plus 3. So this negative e to the n give us negative 1 to the n e to the n. I have 1 here, we have 1 there. So negative 1 to the 2n e to the n over 2 to the n plus 3. So as we know, this will be always to an even power. This is always 1. So this is not an alternating series anymore. Based on the nth term test, as n go to infinity, the limit is 1/2. So this will be divergent. When x equals e, we plug e in. This will be still an alternating series. So based on the alternating series test, it will be also divergent. So the radius of convergence will be negative e to e. These are all the solutions for this problem.